Welcome guys. In this video, we will cover Docker networking. Docker networking is a huge topic. I will try to cover the most important ones and will be helpful for managing Docker. Docker networking, when you create a container, Docker will create a virtual interface called Docker 0. So let's get into the system and find out what's inside the networking concepts in Docker. So we could put Docker network ls will display you the current Docker networking things. We will have bridge, host are the two important things that is normally being used. So Docker bridge. So when we go into the system, we type bridgectl show. Bridgectl show will tell you the Docker is assigned to an VLAN interface VETH FLAC 678. So Docker 0 is a very important bridge, and if you try to alter or do modify this one, we won't have a proper connectivity to the containers. Docker 0 is considered as a virtual Ethernet bridge which is capable of sending and receiving packets to any network interface attached to it. This is how Docker containers is able to interact with the host machine and other containers. When a container is created, a pair of peer interfaces are created by Docker. It is like a two sides of a pipe. If you send the packet to one side, it will reach the other side of the interface. So when the peer interfaces are created, one will act as an ETH0 of the container and other will expose the namespace having a unique name that starts with VETH. The VETH interface is connects to the Docker 0 bridge, thus forming a virtual subnet for containers to talk each other. There are many options available while configuring a Docker. Most of the commands we will go through in this session. So in a Docker, we also have an IP tables and NAT table that plays a vital role in packet forwarding, mostly post routing and pre-routing on the traffic. So we will see the Docker commands now. Let's create a new segment and attach it to a container. Meanwhile, I will try to have few information on how to update the DNS and host names into a container. So you can see it automatically updates the result.conf file, the google.com. So ping. I hope we don't have this commands. Okay, yeah. So I can go externally and resolve any domain. Right. So firewall is blocking. So no worries. And at the same time, let me remove the okay Docker rm. So let's add an host name to the Docker. So I got the host name and as well as the sort.conf file. Name ctl. Okay, so it's not the okay. So I in this command I can push variables with DNS, and at the same time I can assign the host name, and I can provide the bridge to the Docker network type is how to connect, whether host only whether I can connect host only or it's a bridge network only. So in this way, I can isolate my container to either to communicate internally or externally. Now, let's create a new network and attach it to them, attach it to the segments. Okay, so network inspect bridge. So this will tell you the inspect is a very important command which will will be helpful for troubleshooting issues when we which we have or what is our bridge, where what is the segment of that bridge, and what type of driver we are using, and how it is connecting to, and what binding interface we are mapping to as well. So you will find both the subnets and the gateways on the Docker containers. Now let's create a new bridge or new segment. Sorry, let's create a new segment. Now let's show the Docker network. So I got a new subnet, and now I'm going to, okay, let's create, and with the subnet IP and gateway. Okay, so let me remove the subnet first, rm new subnet, and then we will create with the I want a segment with starting with 192.168.2.0 with the gateway 192.168.2.10 segment. So this is my new subnet. So I'm going to launch a container and assign it to the subnet. So let me put it as an isolated web server, and I will share my segment details. So I launched a new subnet. The new subnet is 192.168.0.24, and the gateway is 192.168.2.10. Now I'm going to launch my web server into an isolated mode. So you can see the web server is up and running. Now let me inspect the container ID. We will see what's the IP address. Okay, I'm getting as 192.168.2.0. So what's the IP address is, yeah, so one, let me pull the web server now. Yep, here you go. We get the web server. We're listening on an isolated network inside the Docker container. And let pull me the MAC address for that. Instant ID is isolated web server. So you can see there's a MAC address assigned to a Docker container. It's an isolated my isolated web server. So when we create any new Docker container, it will provide an IP address, MAC address, unique MAC address onto the container. Now let's, and Docker also has an important function. It has an capability to provide on a JSON format, so which will help us to fetch our data, like what's a host name, what's a domain, what's a user information, and we can convert and populate this data, and we can keep it as an inventory, as at what state is it, and all those informations we can get it on the Docker. Actually, in this video, we have saw the commands for the Docker creations on network, how to create a new bridge, how to assign the IP address. But these things will not be sufficient when it comes to the Docker networking infrastructure, because we will have lot of technologies evolved into the provisioning part on the Docker. So we have certain tools which can overcome this thing, but I won't be able to go in deep into it. but I will cover those topics as well. Okay, so in this slide, I want to explain how the packet forwarding normally works onto the Docker container. So in earlier video, I couldn't able to explain much on that part. So in this video, I will cover those things. So what's really happening is that is like when a packet comes into the server. Okay, so on the interface and it's bridged to Docker 0. So when any packet is being transferred from the container will pass into the Docker 0 and go via ETH 0 because IP enabled forwarding is basically true, which is enabled as is forwarded as enabled as 1. So it will act as a router. So from the container to the external world, it will go all via the Docker 0 and interface ETH 0. At the same time, if I use an IP tables packet drop onto a container, so there won't be any communication on towards the external world. So by enabling IP forwarder, users can communicate possibly between the containers and the external world. It will also it will also be required for the internal container communicate. If you are in a multiple bridge setup, this is how this infrastructure will normally work. Okay, so on overlay networks, so as I discussed, the networking is is a huge topic to cover. So I will cover some few informations where Docker technologies evolve with networking. So overlay network is a SWAM scope driver. Overlay network decouples the network service from underlying infrastructure by encapsulating one packet inside another packet. Overlay network is built on top of an underlying network infrastructure. The purpose is to implement a network service that is not available in a physical network. Network overlay dramatically increase the number of virtual subnets that can be created on top of a physical network, which in turns support multi-tenancy and virtualization. Every container in a Docker is assigned an IP address which is used for communication with other containers. If a container has to communicate with external network, you set up a networking in the host system and expose or map the port from the container to the host machine. With these applications running inside a container will not be able to advertise their external IP and ports as the information will not be available to them. The solution is to somehow assign a unique IP to each Docker container across all hosts and have the same networking product that routes the traffic between the hosts. There are different projects to deal with Docker networking. So Vue, Funnel, Open vSwitch, Pipework, Calico. So there are a lot of networking types and technologies or tools which is available to deal this thing. So Funnel provides a solution by giving each container an IP that can be used for a container to container communication. Using packet encapsulation, it creates a virtual overlay network over the host network. By default, Funnel provides 24 subnets to host from which the Docker daemon allocates the IP to containers. The following figure shows how the communication between the containers using Funnel. Funnel runs agent as a funnel D on each host, and it is responsible for allocating a subnet lease out of pre-configured address space. Funnel uses etcd to store network configuration, allocate subnets, and an auxiliary data. Funnel uses the universal tune tab devices and create an overlay network using an UDP encapsulation IP packets. Subnet allocation is done with the help of an etcd, which maintains the overlay subnet to host mapping. Funnel is a virtual network layer that provides a subnet to each host for using a Docker container. It is packed with the core OS but can be configured with other Linux OS as well. So this diagram will show you how a funnel daemon is used into a Docker container. Open vSwitch. This is an advanced bridge that proves programmable and supporting tunnel. Docker, it is popularly called as Docker OVS. Open vSwitch is a powerful network abstraction. The following figure shows the OVS network interacts with VMs, hypervisors, physical switch, virtual switch. Every VM has a NIC associated with it, and every vNIC connected through a virtual interface with virtual switch. So OVS uses a tunneling mechanism such as GRE, VXLAN, or STT to create a virtual overlay instead of using a physical network topologies and an Ethernet components. Project Calico. Calico provides a scalable networking solution for connecting containers, VMs, or bare metal. Calico provides a connectivity using a scalable IP networking principles as layer 3 approach. Calico can be deployed without overlay or encapsulation. The Calico services should be deployed as a container on each node and provide each container with its own IP address. It also handles all the necessary IP routing, security policies, and distribution of routes across a cluster of nodes. The Calico architecture consists of four important components in order to provide better networking solution. FlexX. The Calico worker processor is the heart of a Calico networking which primarily routes and provide desired connectivity to and from the workloads on host. It also provides the interface to kernels for outgoing endpoint traffic. BIRD. The routing distribution open source BGP exchange the routing information between the host. The kernel endpoints, which are picked up by the bird, are distributed to BGP peers in order to provide inter-host routing. Two bird process runs in a Calico node container, an IPv4 bird and one for IPv6 bird 6. Confd, a template processing to auto-generate configuration for bird and monitors the etcd store for any changes to BGP configuration such as log levels and IPAM information. Confd also dynamically generates bird configuration file based on data from etcd and triggers automatically as updates are applied to data. Confd triggers bird to load new files whenever a configuration file is changed. Calico-CTL, the command line used to configure and start the Calico services, even allow the data store to define and apply security policy. The tool also provides a simple interface for general management of Calico configuration, irrespective of whether Calico is running on a VMs, containers, or bare metal. So we have deal on the Docker networking part. So let's go to the next video. On the next video, we will be covering on the Docker file. Thank you all.